Hello, everyone, and very good afternoon. Welcome to the last session of this i4Trust training camp, where today we are going to cover first the technical deep dive of iSHARE, followed by some concepts in i4Trust IAM mechanism, which are basically based on iSHARE. After which a session will be conducted on i4Trust Marketplaces, explaining to you the whole marketplace functionality. And in the end, and presentation where we will explain the overall i4Trust building blocks using a reference example, and how all these individual components that you have been learning about since last few days, how they all come together and help you in setting up your own data space. So let's begin with iShare first. So today I'm going to present about the technical deep dive of iShare, which is an extension of the iShare session that we had on Monday. Let's begin. A quick recap in the iShare role model, which I explained previously. I'll briefly explain. So in iShare, as you can see on the screen, is what the role model is, where you have in the red color the icons which are for data consumer, data provider, and data owner. Right. So these are the parties who are interested in exchange of data. And in the middle layer, you can see certified parties, as we call it in iShare. They are the ones which provide roles or services within iShare framework and within data spaces to these data sharing parties that enables them to share data in a secure and trusted manner. Let's go through each role a bit. The service consumer or data consumer, sometimes as we call it, it is basically a role where you as a service consumer, you consume particular service that is provided by service provider. The service consumption doesn't always necessarily mean that you always consume data. You can sometimes also provide data, by the way, and that is why we call it more of a service consumer. It can be a human or a machine, and accordingly the flows, machine to machine or human to machine flow, are applicable in that sense. And when it is a human service consumer, it always uses an identity provider to identify itself to the service provider, right? A service provider is mainly in this context providing services related to data, and not services like authorization registry, identity provider, marketplace, or those. So in this sense, it is a service provider whose services are being consumed by the service consumer. Normally, the data owner or entitled party uses a service provider to maintain its own data, either because it has this service provider is its ERP or CRM or other backend system provider, or similar systems, or in any SaaS solutions that service provider is hosting, and as a result, it already has all that data from the data owner, and data owner simply authorizes service consumers to get data directly from the source. So these service provider are more from that perspective. And for service providers, again, they have to support both. In iShare terms, they have to support both flows, machine to machine and human to machine. These flows will have a deeper look in a bit. And of course, they are the ones who determine what data to provide how, along with the entitled party. Some reference open source implementations of service providers. Some links are there that you can see on the screen. They are the GitHub links to some open source reference implementations. Entitled party, sometimes also we call it data owner, is basically a party who has entitlement or the first right over the data in the question that service consumer is interested in getting from the service provider. Um, Remember, these are roles, and it can happen that the service provider and entitled party are one and the same organization, but they can play both the roles at the same time. For example, because they own their own data and they host the services as well on their own infrastructure. That is a very well valid scenario, and in that case, it itself becomes entitled party. However, when it is a third party service provider which is just acting on behalf of an entitled party, then usually these are different organizations. Irrespective of that, entitled party remains the entitled party, no matter who hosts the data, and only it has the right to give access to relevant other organizations to that data. Let's look at some of the certified roles that we have defined in iShare. iShare Satellite is a role which is essentially a directory of all the participants. iShare Satellite is actually based on distributed ledger technology based on Hyperledger Fabric. So every satellite is just a node on that network, and that what that means is when a participant is registered at any of the satellites, and that participant is uh, equally visible in all other data spaces where other satellites are there. So that allows you to have a basic level of interoperable trust between participants even across different data spaces. uh, but obviously, within a satellite or within a data space, the satellite of that data space facilitates the discovery and the trust aspects for any participant or between the participants of that data space. So how that is done, we will see it in a bit in with an example of how iShare flows work, and as part of that, how you as a participant can trust the other participants within the same network. The identity provider role is defined in iShare such that identity of humans are stored or presented or authenticated within the network. So all the service providers can use or connect to any identity providers, um, and as well as all the service consumers, specifically the human service consumers, can choose their own identity providers to authenticate themselves to any of the service providers within the data space, right? It is essentially based on or derived from OpenID Connect, the flows and the way it interacts with each other. However, there are some modifications necessarily made in order to make it suitable for organization to organization data sharing, um, uh, as opposed to OpenID Connect, which is a general standard for general internet use, where it also caters to public services or social services like social media and others. The key difference between these two is that you need a certain level of assurance as minimum when you are dealing with organizational data versus on social media, for example. Of course, the framework itself also supports various level of assurances of identity providers as well as of the identities. So the service providers, depending on the criticality of the data, may require that identities are assessed at certain level of assurance, which gives them enough trust in order to share the data with right party. Right. The other role that is defined as certified role in iShare is the Authorization Registry. The Authorization Registry provider role is basically a service provider who provides or facilitates entitled party to enable describing authorizations for its data to service consumers, right? And the authorization registries, providers can choose how they implement the authorization registry itself, and all they have to do is make sure that they implement the iSHARE compliant APIs that are mentioned in the iSHARE specifications. They can use multiple sources of data, like policy database, backend systems of the service provider or entitled parties, even the Active Directory or directories where organization stores rights and identities of its own employees and applications, and various other sources possible, and determine on the fly, if necessary, whether a party should have authorization to some data or not. Right. Well, that was about the role model, and today we will look at also what iShare brings, and that is essentially focused on trustworthy identification, authentication, authorization. Remember that iShare is data agnostic, so what data you want to share and how you want to share it with any connection mechanism, as well as in any standards, using any standards or formats. iShare does not restrict you from that perspective. However, in order to share any data, you can logically talk about it in two steps. The first step is, before you share the data, you want to identify, authenticate, and authorize. Check the authorizations of the party with whom you want to share the data, and then the actual data sharing follows. So, what elements, or how iShare enables in these aspects is what we see on the screen. So we support different interaction models, so machine to machine and human to machine. We'll look at these flows in detail. What it facilitates is basically flexible authorizations. We'll also have a brief look at the policy model, which the request response model of authorization registry APIs are based. Of course, authorization registries are free to also store policies in the same format, but they can choose to store policies in different formats as well. But to explain the advantage of using this authorization model, which allows you to have a lot of flexibility in terms of what you define as policy, as well as portability of identities. As I mentioned earlier, that human service consumers can choose their own identity providers to authenticate themselves to any of the service providers, as well as they can switch to different identity providers when they want, without having necessarily impacted the whole flow of how they identify themselves to the service providers. And in all, what this enables is possibility of doing delegations. So not only can entitled party authorize just a service consumer, but it can also authorize and service consumer, but service consumer can further delegate those rights down to its own partners or vendors. And in the end, this enables, with the delegations of the rights, what it enables is that the data which the party should consume is consumed directly from the source. So you always get up-to-date information, and reduce the inefficiencies that are seen usually in the paper-based business operating models. Further, there is the customer in control, or the data owner is in control, because when it specifies the authorizations, because it can specify it on attribute level, it gives particularly granular access rights possibilities to be authorized to service consumers, but at the same time, it also has facility to provide with data licenses, which essentially control what the consumer of the data can do with that data, even after it has been shared already with them. So and this is all, of course, protected by the legal framework that iShare brings. So it's not only about just giving the rights, but also controlling what the other party can do with that data. Let's have a deeper dive into any IAM transaction that happens in iShare using iShare framework. These are the basic elements we see in all the flows. You will and here I attempt to make it more familiar to you, all these concepts that we use in iShare. So four key elements that we will talk about is certificates, which basically means digital certificates. JWTs. I will only briefly introduce JWTs because it's generally known JSON Web Tokens, and there is a lot of material available from the specification itself. So for further reading, you can also refer to that. What we call as client assertion in iShare, what it is, and when to use what, and an access token. So in the end, yeah, the IAM transaction can only happen once you have a token, or data sharing transaction can happen only once you have the token, right? So let's understand first what is a digital certificate. It's a digital file used for integrity and authenticity, to prove an integrity and authenticity of information or the claims that it has. It is essentially at a very base level, it's a pair of keys, basically public key and private key. Public key, of course, means that you can share the public key with the world, and private key is basically the one that you protect with yourself, and you never share that key with anyone. Digital certificates generally provide information about the owner of the digital file, and as well as more details about um, what that certificate is about. And for example, when it is about SSL certificates, which are used for HTTPS connections to websites, it also includes information about the domains that are for which this certificate is valid. But there are other types of certificates as well, like organizational qualified seal certificate, which allows you to digitally sign on behalf of your organization as an authorized person from that organization, and various others. Certificates are not only used for signing, sometimes these digital certificates are also used for encryption purposes. So depending on the use case and the types of certificate, you can use them for various purposes. So as I said, a digital certificate has two parts, public part and private part. And together, some certificate formats support you to have both the keys in one file, whereas some certificate formats do not allow that, and you have to store them as two separate files. Here on the example on the screen you see is a P12 format, which allows you to store both public key and private key in a single file. iShare relies quite a lot on the PKI certificates to verify organizational identities. As I've already explained, iShare uses one of the key self building blocks called EIDAS, and it uses extensively digital certificates in order to establish the validity of any identity tokens that are there. We'll see how that is arranged in a bit, right? And of course, what is private key is private key is used to either sign or encrypt information. And with that private key, whenever you have signed, it can always be validated using the public key, corresponding public key. And that's why you need to share the public key with all the parties that want to validate your signature. However, you never share your private key with anyone, because with that they can also sign on your behalf. As I mentioned, there are various encodings and file formats that are there for a digital certificate. Some of them are listed here, which are most commonly found. And you can see that they are basically categorized into two formats. One is which is based on base64 format, and one which are binary types. So we saw an example of P12 file, which is actually a binary type called PKCS number 12. This is a binary format, and that is why it allows you to store uh, both private key and public key in the same file, and it is always protected with a password. um, but more details can be found about these specific types over if you look for them on internet. But keep in mind, when you see these file extensions, you know that you are looking at digital certificates. I've included some information, general information for your help. Specifically, there is a cheat sheet that we have provided in order to understand some basic concepts of digital certificates, as well as there's a basic script available in iShare GitHub, which allows you to convert a digital certificate or extract digital certificate in the formats that you need to use in iShare. Let's continue. So then let's move to the next topic, that is JSON Web Tokens, or JWTs, or JOTs, sometimes as people call it. What are these? It's basically and base64 encoded JSON objects. And most of you must be familiar that JSON um, is a standard for storing or structuring data in key value pairs. Of course, it also supports nesting of information, but it is a much more simpler format as compared to, say, other examples like XML, right? But what is JWT is basically, it is also a JSON object, but a base64 encoded, and it is essentially can be seen in three different parts altogether, which make a JWT. So as you can see on the screen, that the first part is the header. So it gives more details about the object itself, and it has some attributes which specify what that object is about. Then is the payload, where you will store all the data that you want to send to someone. And the third part is the signature, where based on the first two parts, the first two parts is header and payload, is what you use, what you with the private key you sign that information, and the resulting information is the signature, and that is the third part of a JWT. So as you can see, what you input versus what you output on the right in this table, and when you attach that all together with combine those three different parts with a dot, that together represents a total JWT. So with this basic understanding of JWT, we will introduce you to the concept of what we call as client assertions. A client assertion in iShare is essentially a JWT for which we have specified how that JWT should look like, right? This is a client assertion is usually an identity claim token. Basically, I, as a consumer, I will generate my own client assertion with the claims about my identities, and I will sign it and send it to the service provider to identify myself. That is, in essence, what we call as client assertion in iShare. So as we have defined how the JWT or client assertion should be created. So in header, we need these three attributes to be specified always, and with these values, specifically for AL algorithm and the type. For XYC, the value is basically your XYC digital certificate or the public part of your certificate. And in the payload, we have defined all the attributes that you need to specify based on your identifiers, as well as the time. The different time and the expiry time of this client assertion, right? Once you have this information, how do you generate a client assertion is basically using your private key of your EIDAS certificate or equivalent certificate. Basically, you combine the header information and payload information, and you sign it with your private key. So you get the third part, that is your signature. And when you combine that all together with a dot, for example, as previously explained, then you get a total JWT, which is what we called as client assertion iSHARE. This is an prerequisite step in order to connect to any other party in iSHARE, that you generate this client assertion for yourself. So we'll have a look at the machine-to-machine flow in a bit. But essentially, here I'm explaining that when a service consumer called ABC Trucking Company server wants to connect to Warehouse 13 server, which is a service provider, then it simply generates the client assertion on its own. The ABC Trucking signs it. It's a signed JWT, which it sends at the token endpoint of the service provider, saying, "Hey, this is my token. Can you validate and give me an access token?" So in the client assertion, you can see that this is how the request is sent, and a client assertion, that is the JWT, is attached in the request. On the service provider side, the service provider decodes that client assertion, validates it on various parameters, and when it is satisfied that it is indeed the authentic identity token, then it issues an access token, a bearer access token, back to the service consumer. Using this token, basically now service consumer can request any data from service provider, provided of course the service consumer must have authorization to access that data, right? So let's in the following slide, you will see that I'm talking about machine-to-machine flow, M2M as we call it. And on this screen, you can see some highlights about this flow. On the right, you can see also the sequence diagram of how a typical authentication sequence looks like in machine-to-machine scenario. In iShare, it is important to remember that data is always shared between two organizations directly. So it's always a peer-to-peer connection and peer-to-peer sharing of data. Third party, or there is no intermediary who needs to get your data in between in order to pass you the data. This may it may happen that you need a translator service in between in some cases when you cannot understand the data formats from other providers. In that case, you may designate a translator to act on your behalf to get the data. But essentially, what iShare enables is peer-to-peer data sharing between two organizations. As I already explained to you, a client assertion is a way or an identity token of service consumer that it sends after signing to the service provider to authenticate itself as an identity, right? The flow, this flow and the further details are explained. You can find the link here to our dev portal where this is explained. Similarly, for human to machine interaction, a similar flow is there. However, because now, of course, it's not two servers talking, but also a human element is present, which needs to interact with either a portal or an application. The steps are a bit different because now you also introduce identity providers. Because remember that humans in iShare are always represented via identity providers. The reason is that the identity providers maintain certain level of assurance while onboarding human identities onto itself, so that the other organizations or service providers can be um, assured of the identity of a particular human representing a particular organization. And because this is business to business data sharing, you need to be sure that you are sharing the data with an employee of the organization with whom you intend to share this information, right? So again, here in this case now, the sequence diagram is further explained, and you can find the full readable format of this sequence diagram on the link here, which is also on our dev portal. Let's take a quick look at the policy model that of authorization registry that I was talking about. Note that here I'm only explaining the model of this policy, but it is not mandatory for authorization registries to store policies in this model. However, you can see the benefits of using this model, and you may choose to store your policies in this model. So you can see at the beginning, you see the not before and not on or after. That specifies the time when this policy is active. So you can specify it for few seconds to few years or forever based on that. Then you also see the policy issuer and the access subject. So the issuer is the identity of the issuer of this policy. Essentially, this issuer has rights over the data resource that you will see in the policy set. And it is the further authorizing the access subject to whom it grants certain rights on this data set, right? Then you can see the max delegation depth. You remember we talked about delegation and the possibility for data owners to keep control of data even after it has been shared. So with these elements, the data owner remains in control by for specifying that with the delegation depth levels, basically it can restrict for further delegation limitations on the authorizations. So when the delegation depth is set to 0, that means the receiver of this rights cannot further delegate this rights to another organization or another identity. However, in this example, you can see 5. That means company A will delegate this rights to B, B to C, C to E, D, and D to E. That's a level of delegation that is allowed in that perspective. And you also see licenses. Here you see iShare.001. That's a tag for the data license. You can also find these data license specifications on iShare website. But these are essentially the data license tags, and each data license tag means something. It restricts the access subject in this case in terms of how they are allowed to use this data when they receive it. Example of this usage condition can be that the access subject can use this data only for once, and especially only when they are transporting the goods, because the example is about container. That's one example. The other example, very open, could be that the policy issuer does not, or the data owner does not mind how the access subject is going to use this data. It's sort of an open data for them. That could be another end of spectrum of data licenses. So that is about control. Now you can see an example of resource. So in this policy model, a resource is essentially a data set which you want to control or give rights to. and basically it has three open text fields, basically type, identifiers, and attributes under resource. um, the values within this are not defined in iShare, so it is up to the participants involved what they want to store and share with each other, and define what these types, identifiers, and attributes can be. So it can be, as you can see in the example, this is based on GS1 standard. The container and the as a type, the identifier is marked as currently as wildcard. So of course, identifiers and attributes can contain wildcards, but it can be very specific. Like attributes are specified that it can only read or write to ETA or weight information of the container, for example. However, as I mentioned, these are open text fields, so you can also put URNs or reference to existing data standards or smart data models, for example, which define what type of resource it is, and you can define them based on type, identifier, and attributes. Then you see within that actions. So these are the actions that are allowed on the resource, basically. Here it is an example of read and write, but you can also use different actions like HTTP methods, for example, get, put, post, or other examples that you may think of. Again, this is not predefined in iSHARE specifications. You are free to use actions which are understandable within your data space by participants. There is an additional environment which is optional, that is environment under which you see service providers. Assuming that you use this policy model for storage, the idea here is that when you specify a service provider identifier, then this policy is only applicable when the access subject is accessing this resource from this service provider. So, for example, you use two or more service providers, and your data is residing at both of them, and you want to restrict access to this particular access subject to only one of those, then there you specify the identifier of that service provider where this access subject has rights to. So when this access subject goes to another service provider of yours and try to access the same data, it will be denied because it is not listed um, in the service provider environment attribute. Then you look at the rules section. So first rule, that is effect is permit, is mandatory in this model, in the sense that whatever resource you have mentioned up above is what you are essentially permitting to. And additionally, you can specify exceptional scenarios. So in this example, you can see that resource of type container with any identifier is allowed to be accessed by this access subject. However, deny it when the container identifier is this one specifically mentioned here. And an action is to read that information about the weight. So when this is the situation, it will reject it, else it will permit it. But this is just to give you an understanding of how this model looks like, and you can choose to store your policies using this model. Now, why I introduced that model to you is basically the iShare, the AR's request and response model is actually derived from this model. And here on the screen, you can see the example response that you as a service provider will get from an AR when you ask if a certain access subject has rights to some information that it is seeking for, right? So again, the policy issuer is basically who issued this authorization to this access subject. And when you ask that, okay, this subject wants to access, say, read ETA and weight information of a container, based on this policy, basically will get, yes, it is permit. That is what it is allowed. So you can allow this access subject to read ETA and weight from a container. Yeah, that was more about the AR. Now I've introduced you to all the concepts. Now let's look at a fictional use case and how these flows work in detail. So step by step guide in that sense. Um, uh, of course, remember the concepts that I just explained to you, and these are what we use in order to achieve the desired result. So with this fictional use case, let me introduce to the case itself. So on the screen, you can see that there is a warehouse, there is a transporter, and there is a company, um, which is actually hiring the transport company to pick up its container from the warehouse, right? So it's a banana company and it has its parcel or container coming in at warehouse, and it wants that ABC trucking company to pick it up on its behalf. Um, this is a very simple flow. Of course, there are more parties involved, but to simplify it, we keep it very simple for time being. So how do you map them in the iShare role model is basically, you can see that banana and company is basically freight owner, which is basically from iShare perspective is an entitled party. So it has the first right to the information about a container which is sitting at warehouse. The warehouse 13 is basically a terminal provider, and in iShare perspective, it's a service provider because it has, though it maintains containers, but on the digital twin version of it, it also provides with information about the ETA and the weight and other aspects of the container, right? The ABC Trucking Company, which acts as a transporter in iShare terms, is a service consumer because when it wants to pick up the container, it needs to know ETA, it needs to know weight and other elements from the warehouse or from the banana and company, ideally into in general world. However, with iShare, the power is that ABC Trucking Company can directly fetch that information from warehouse 13, thereby increasing the possibilities of making much more efficient transactions. And Banana and Company, since it's an entitled party, chooses its own authorization registry. It is called Ask Me Anything Authorization Registry, which it uses to store authorizations, right? Some preparatory steps when you are actually implementing and running any test using iShare mechanism. There are some steps which all participants of iShare need to take. And first one basically is that iShare also issues via its satellites a trusted list. There is an API which you need to call. It gives you a list of all the CAs, of which certificates issued by these certificate authorities are trusted within the network. These are carefully selected CAs based on various parameters which enable trust in the network. This is achieved because these CAs only issue certificates of certain level after they have performed certain level of validations, and these certificates are usually allowed to be used as signing digital certificates. So the parties which are using the certificates can actually sign information using the certificates, and these digital signatures are legally acceptable in any in the country where or in the region where these certificates are issued. So they do stand valid in legal in the court of law as well, and that is the essential that is very essential when you are talking about any trust framework, because when you share this information which is signed, you can only trust it when you know whether about its assurances, right? um, Participants can play different roles as I've explained, and in this perspective we are looking only from this use case perspective. So these organizations, as they are mapped currently to the iShare roles, this only applies when we are discussing this use case. When we discuss another use case with the same participants, for example, they can be playing different roles as well. Yeah. So this is about the trusted list. As I mentioned, all organizations should cache this list and update it regularly. This step is not necessary to be called always just before any machine to machine or human to machine transaction happens. However, if your cache is invalid or old or stale, or you haven't cached trusted list, then you have to make sure that you call this, because then you have all the trusted CS of which you can um, uh, so that you can validate the certificate and the signature from the client assertions that you will receive, right? Now let's look at how the M2M flow or machine to machine flow in this scenario, that or how do we achieve the fictional use case requirement based on this flow. As I mentioned, the Banana and Company is the entitled party who has a container at warehouse 13. It wants to it wants ABC trucking to pick up that container from warehouse 13. Sorry. But of course, when ABC trucking wants to pick it up, it needs to know when it is expected at a warehouse, and various elements like its weight, its category of the content of that container, etc., so that it can take appropriate measures in order to pick up the container from warehouse. In traditional world, how that happens is ABC company goes to Banana and Company and asks it all this information, and Banana and Company has to go to warehouse 13 to fetch many of this information, specifically the ETA and the updated weight of the container. So as you can see, when more and more parties are involved in this chain, because this is a simplified version of this logistics chain, it is very much complex to fetch the up-to-date information in real time. However, now we'll see with this example how Banana and Company can give rights to ABC Trucking, so that ABC Trucking can directly go to the warehouse and get all the information that it needs. So first step, and this happens as a pre-step in before the transaction happens. So as a part of regular business process, when Banana and Company makes a deal with ABC Trucking Company to manage its container pickups, it registers in its authorization registry that it has given certain rights on certain attributes of containers that it expects ABC Trucking Company to handle from warehouse 13, right? So here it simply says I delegate rights to access data regarding containers X, Y, and Z, which are the containers at warehouse 13, on behalf of a ABC company, right? And it informs the ABC Trucking Company that okay, I have arranged for your rights digitally. Now you can directly go to warehouse 13 and fetch all the information you need in order to plan the pickup, right? So in this case, now actual transaction happens, or now we are talking about the actual flow of when ABC Trucking company wants to know about the ETA of the container from warehouse 13, then how will it initiate this transaction, right? So first step, as I already explained a bit earlier, is that ABC Trucking Company server needs to connect to the warehouse 13 server, and it needs to first get an access token. And this for this, what it does is it generates a client assertion at its end and sends this client assertion at the connect token endpoint of warehouse 13. Then, when the warehouse 13 receives the client assertion, what it does is it validates that client assertion, checks the certificate which was used to sign that client assertion. Then it also wants to check if this company is known in the network or in the data space. So the service provider or warehouse 13 in this case first connects to the satellite of the data space. So again, it's a similar process for service provider when it connects to satellite. that it first needs to get an access token. So it service provider then generates its own client assertion, which it sends to the token endpoint of satellite. And the satellite validates this token and validates if the warehouse 13 is a known participant in the data space. And then it generates an access token as a response, which it sends to warehouse 13. With that access token, now warehouse 13 can actually ask for the, the details about ABC trucking with its identifier, as you can see here. And it can do so with the querying on the parties endpoint of the satellite. So in the parties endpoint, it simply sends, okay, I need information about this identifier, who this identifier is, and for the details about it. And in response, a token from satellite is sent, which includes all the details that are known at the satellite about ABC Trucking Company. Remember that iSHARE satellite itself is not a certifying authority or anything. It does not issue any kind of certificate. It does not sign your identity tokens or anything. It simply gives the information that is stored in the satellite. And with this information, the service provider now can validate this information against the claims that it received from the ABC Trucking Company in the first step, right? So after it has validated all the aspects of the client assertion and also the validity of the signature or that was in the client assertion, and after it has been satisfied with that, then the warehouse 13 issues an access token to ABC Trucking Company. Now with this access token, it can simply raise any of the data endpoint. In this case, it's the service provider / service is the endpoint at warehouse 13, where it says, I want to get details about the container Z, as in when is the ETA, when it is expected to be arriving at the warehouse, and my delegation rights are at Ask Me Anything registry. Well, there are various flows, various supported ways in which service provider knows where to check or which authorization registry to check for the right authorizations. This is one of the ways where the service consumer specifies that it can find authorizations at a specific authorization registry, right? Um, so in this case, because the warehouse 13 is informed by the service consumer that it has to check for the authorizations at Ask Me Anything or authorization registry, then service provider needs to know how to connect to Ask Me Anything authorization registry, as well as to check if this Ask Me Anything authorization registry is also a recognized participant within the data space, right? So what it does is, again, it goes to the satellite with the same step that if the token is not valid, it gets an access token first by sending a client assertion of itself. And then now it gets the details from parties endpoint with the identifier that was shared by service consumer of the authorization registry. So in this case, it's the identifier of the authorization registry. It says, okay, give me all the details that are known about this authorization registry. Satellite gives the details about the authorization registry back to service provider. And in that response, there is a capabilities endpoint, which is referring to all the services that are exposed by Ask Me Anything authorization registry. And in that capabilities endpoint, there is an entry of an endpoint called delegation endpoint, which all iShare based AR must implement. So service provider simply has to look for that delegation endpoint from the capabilities endpoint of that authorization registry, right? And that way it knows basically also how to connect to the token endpoint, also from the capabilities endpoint of the Ask Me Anything registry. So now first step again, as it is machine to machine transaction, service provider generates a client assertion and sends it to the token endpoint of authorization registry, Ask Me Anything. The authorization registry follows the same steps in order to validate the client assertion. So it validates the JWT, it checks the certificate, checks the signature, and now it also wants to check if Veras 13 is a known participant in iShare satellite and the data space. So for authorization registry, it will again connect to satellite with first get a token. Get a token from the satellite, and after it has got the token, it connects. It calls the parties endpoint basically to get more details about the warehouse 13. Once it has got the details about warehouse 13 and validated it along with the client assertion, then it will return an access token to service provider, right? With the service provider having that access token, it will raise this question on the delegation endpoint of authorization registry, asking if the ABC tracking is allowed to have access to data of container Z. Remember, this is explained in simple English. However, the request is sent in the policy model as I explained earlier. So there it will simply generate a JSON where it says where the access subject is ABC tracking and the resource is gs1.container with an identifier Z, and whatever attributes that ABC tracking company is asking for is included in the request, and the action, as in is it asking to read that information? In this case, yes. So it will send action as read. So, because if you remember in the first step, Banana and Company made that policy in the authorization registry, which allowed access to ABC Trucking Company on the container set. The authorization registry determines yes, ABC Trucking Company should have access to information of container set. So in response, it sends that response similar as explained in the model that I previously explained. But in plain English, it simply says yes because it is permit because there is already a policy in it, right? With that, warehouse 13 checks all the evidence. Again, when authorization registry sends back the response, it is also a signed JWT, so that service provider can be assured that it is indeed a valid information that it can trust in order to share data with service consumer. So before it sends the data, it of course needs to validate the response token itself. So it checks the evidence and the certificate which was used for signing and everything. And when it is satisfied, it will then send the container data back to the service consumer. So this is how a simple machine-to-machine flow looks like when using iShare. These are here, as you see, only servers are involved. So no human identities are necessary, but only organizational identities, because servers belonging to organizations are talking, and they are able to establish trust based on signed tokens, which are signed using digital certificates. Now let's extend this use case a bit to explain to you the human to machine flow, right? So the example is more or less the same. However, now there is an addition of a service consumer, a human service consumer in this case, that's called driver X. A driver X is actually a trucker within the ABC trucking company. And there is a introduction of different authorization registry in this case, which is called registry X. And there is an identity provider called Secure Logistics that is being used by the ABC trucking company or driver X to identify itself. So let's have a look how this flow would work. As I explained, driver X is an human consumer, and this is a trucker from ABC trucking company, which is a transporter, right? So the pre-steps here that happens before the actual transaction happens is Banana and Company delegates the rights to ABC trucking company. This is the same step. This is an delegation between two organizations. So Banana and Company is giving rights to ABC Trucking Company that it can manage the container pickups from warehouse 13 for on its behalf. Um, and Now, for the simplicity sake, we are storing both the Banana and Company and ABC Trucking Company. Both are using a registry X as their authorization registry. However, both parties can use different authorization registries if they choose to, right? So in this case, ABC Trucking Company is now adding an authorization for its own driver, that is driver X, that it can act on behalf of ABC Trucking Company for Banana and Company. So whatever rights Banana and Company has given to ABC Trucking, ABC Trucking Company authorizes driver X to also have the same rights, basically. Now, in this case, assume that driver is actually on the gate of the warehouse 13, and it wants to open the gate of the warehouse 13 so that it can pick up the container, right? Um, so what will happen is basically at warehouse there is usually a security gate at which drivers are usually asked to identify themselves. Currently, it happens on paper-based process, and there has to be an information flow already from Banana and Company to warehouse 13 that a certain company driver will come and pick up a container at certain time. Because warehouses are a bit restricted towards access because it may have sensitive cargo or expensive cargo, and it needs to protect that from thieves, basically. So in this case, but as you can see that uh, there was no information flow that we explained that Banana and Company sends to warehouse 13, but instead, because the delegations of the rights are already in place, driver of ABC Company can, based on the ETA information that it previously fetched, already arrive at the warehouse on that specific time or around that time when the container is available for pickup, right? So here it is assumed that it is already determined that ETA, and it is now at the front of the warehouse gate, and it is asking the security that can it go inside and pick up the container, right? So how does now that flow digitally looks like? So instead of doing paper based validation of identity, assume that driver X uses digital means to do so. So at the gate, there is a digital way to identify itself as a driver. So driver uses that mechanism, either it's a portal or via the app with a QR code or something. It scans and wants to log in. But warehouse needs to know the identity, so it asks which identity provider driver X would like to use in order to identify itself, so that warehouse 13 can determine whether to allow access to driver or not, right? So it asks driver X, which identity provider would you like to use? Driver X already uses secure logistics, or ABC Trucking Company uses secure logistics for all its employees or drivers. So it says, okay, I can log in with secure logistics to prove my identity. When it selects secure logistics, the service provider sends the driver redirects the driver to secure logistics login portal. Remember, this is based on OpenID Connect flow. So if you are familiar with OpenID Connect flows, these flows should sound very familiar to you, right? So it simply redirects to the authorized endpoint of secure logistics, the driver to that endpoint. In that request itself, the warehouse 13 sends also the client assertion that it has generated for itself. Because remember, in iShare, service provider do not need to register identity providers, or identity providers do not need to pre-register service providers and issue client secrets and client IDs. They can work with any identity provider or any service provider. Both of them can work with either of them. even when they have never interacted or never registered themselves, because they are all registered at the satellite, which they can always verify from the satellite, or they are registered in a data space, so they can always validate each other from that they are registered in the satellite. In this case, the service provider has sent a client assertion of itself to Secure Logistics, and Secure Logistics will now check the client assertion, check the certificate and the validity of the client assertion. And it also, of course, wants to check if Veras 13 is a known participant in the data space, and can it trust and abide by the rules of the framework, right? So the first step again for Secure Logistics would be to get an access token from the satellite. And once with getting the token from the satellite, it can ask all the details about that satellite knows about Veras 13. So using the parties endpoint, so it sends that request and satellite responds back with all the information that is stored in the satellite for warehouse 13. And this includes, of course, the status of this participant as well as capabilities and other various details, right? Um, uh, that's a response of the party token. Once it has validated everything and it knows, okay, this is all part of the data space and this service provider is known within the network, it can trust that, okay, the identity that it wants to log in can it can share the data with the service provider. Um, but of course, Secure Logistics itself needs to know which of the user is trying to log in. So it sends a login screen to the service consumer. Um, Service consumer simply provides its credentials. Now remember that as an identity provider, it can enforce certain level of assurance by enabling or enforcing multi-factor authentication if necessary when driver logs in. Also, depending on the type of login that the identity provider uses, it may or may not be multi-factor, right? Um, but certain level of assurance requires certain level of certain types of login features to be enabled, and this is based on EIDAS framework that determines how to determine level of assurance of the login. Now driver X, because it selected Secure Logistics, it knows its identity provider login screen. It finds it familiar, so it provides all the credentials. It is known within Secure Logistics, and with that credential, Secure Logistics authenticates driver as a valid driver, right? However, in order for service provider to receive all that information, it first sends the code back to the service provider using which it can get an access token, right? So with the token, with the code, a service provider can now request for access token from the identity provider. With the access token, then it asks for all the user information using the user info endpoint. And in this user info endpoint, it gets all the details about the identity of the driver as well as the organization that this driver is representing. So in as I said, it gives the identity of the driver and the organization that it is representing, that is ABC Trucking Company. And service provider then validates this information, and now it knows, okay, this driver is coming from ABC Trucking Company. So it has to check within its own database which containers are belonging to ABC Trucking and whether any of them are ready for pickup. And if they are ready for pickup, because it's belonging, these containers are belonging to Banana and Company, and the company which is here to pick up is ABC Trucking Company. It needs to know whether ABC Trucking Company should be allowed for picking it up. So now it needs to know from the Authorization Registry whether this authorization has been granted. So service provider, because it knows the container provided by driver that it wants to pick up, it knows the Authorization Registry of Banana and Company to check if ABC trucking company uh, is authorized to pick up the container, right? So it sends a connect token to or client assertion to at the connect token endpoint of authorization registry. The authorization registry validates the token, checks the certificate, signature, etc. Then authorization registry also connects to satellite, asks for details about warehouse 13, and with this it knows, okay, warehouse 13 is known in the data space, and it abides by the rules of the framework, and it can then issue the access token back to the service provider. With this token, it checks with the authorization registry if the driver X is authorized to get access to the container of Banana and Company. Now remember that there are two delegations in place. So Banana and Company gave rights to ABC Trucking Company, and ABC Trucking Company gave rights to driver X. So linking these two authorizations, it determines yes, driver X should have access to the container of Banana and Company. So it simply sends yes. Remember, these are explained in plain English. However, the request response model, as I explained previously, it needs to be used in that format for delegation endpoints. Now, since yeah, so as I explained, is driver X authorized to get access to container of Banana? Sorry, I'm going backwards. So authorization registry sends the evidence back to the service provider, which is a signed version, and now service provider needs to validate that and satisfy itself that it is indeed a valid authorization, and use that to give access to the driver to the warehouse premises, right? Because it was able to identify and authenticate properly as well as authorize this trucker, it allowed access to the warehouse premises, all based on data that is already stored or via the means of authorization. So now no more back channel information via phone calls or via emails is necessary, but these use cases can be achieved completely digitally. Yes, that is how the human to machine flow looks like. In a sense, of course, when more parties are involved, this becomes a level complex. But you can always bring down the complexity of your use case to this level by only focusing on involved parties in a use case and the steps that these parties need to take in order to uh, uh, implement the flows like this, right? So, so that was more on the how the flows look like. On the screen now you see on high level the steps, basically the 3-step guide to becoming an iShare participant and utilize all the benefits that iShare framework provides. And the step one is basically you identify your role within the framework. As I explained, you may be playing multiple roles in different use cases, but when you are implementing or a use case, then you are only usually focused on one role, and you should focus on one role at a time to avoid any confusion because of conflicting or overlapping requirements for certain roles, right? Once you have determined your role in the use case, you can go to the step two, where you actually test and develop and implement your specifications based on the role that is given, and to facilitate you to first understand how these roles are implemented. um, on the dev portal you can find videos, postman collections, further explanations of each role or the specifications and the APIs that you need to implement as a particular role. You can either implement them yourself, or you can download the dummy versions that are available on also the GitHub, and deploy them to simulate your use case essentially, or implement them and prove your use case is working. iShare also has a test network where you can register first your test servers and run this whole use case on a test environment. For that, we provide with various components like test authorization registry and test satellite where you can register as a participant. Also, we can issue you a test EIDA certificate. You can request it yourself using the link mentioned here, so that you can use that in during testing your implementations basically. Once you have done all the development and testing of your role as specified, uh, and you are confident that this component now can be taken into production, at that time you can go to step 3, and you essentially also onboard as a participant in iShare. And for that, you procure an EIDA certificate or an equivalent certificate as is mentioned in the framework. You sign the agreements that are there. I already explained some basic idea about the multilateral contract in my previous session, but that is enforced via signing of agreements. So that is terms of use and accession agreement. You can also find these agreements via the website. These agreements are signed by all parties, and for certified parties or certified roles, there are additional agreements that they need to sign. There are some formalities like providing extract of Chamber of Commerce and providing some other documents proving your organization and public key of your EIDS certificate. For example, when you are actually onboarding to iShare to become a participant. And last but not least, more important one is you also provide with the conformance test tool report of your implementation to make sure that your implementation complies to the specification, and this is to make sure that you also remain interoperable with all other participants. In the program of i4Trust mentoring program, all of you will go through steps 1 and 2, and step 3 is what you will take when you are ready to move to production. So it can happen during the mentoring program, or it can happen after that. To reap the whole benefits of the trust framework and the legal aspects, you need to become the participant. Otherwise, you can simply use the technology, but then as a standalone, that technology is no different than what you are using with the other standards that are available. To get the whole benefit of the framework, you essentially become participant of iShare. And with this, of course, I have provided some links, useful links, as I have been mentioning about our website and dev portal. So this is where you will find all the information and links to various elements that we cover in iShare. With this, iShare deep dive is over. I will now quickly move to i4Trust role model and brief explanation about i4Trust IAM. A brief recap of the data space. What is a data space? As I explained in the very first session, that is the introduction session, a data space is a decentralized data ecosystem built by parties who come together with a common purpose. Essentially, remember that data space is a logical construct, and it is created by the participants who are interested in exchange of data. And these parties are mentioned here at the top in the yellow colors, that is data consumers and data providers and data owners by that means. And in order to enable them to do so in a trusted manner within a data space, you need services like identity and authorization services, and services like marketplace and other vocabulary or other similar services, right? This we see as minimum set of any kind of data space that you have, along with, of course, the important aspect of data space governance. So data space governance include also the trust anchor element, which in i4Trust is based on iShare satellite model, right? So with that trust within the data space and the governance within the data space, all parties can effectively and interoperably exchange data with each other, even when they have never done so before. And it avoids bilateral contracts between the participants of data space. So, in introducing to you the i4Trust role model, in as explained in the data space, you have a trust provider, you have a data consumer, data provider, and the data owner, an identity provider role, and marketplace role, and authorizations provider role. So these roles are bare minimum in any i4Trust based data space. And under i4Trust umbrella, iSHARE and FIWARE together brings to you open source components available for each of these roles. For acting as a trust provider within a data space, you can implement an iShare satellite and become an iShare satellite by complying with the requirements of that. For data consumer, open source FIWARE components are available, which can exchange data with NGSI LD format. Similarly, for data provider, which is basically the context broker, so data provider implements usually the context broker and shares data using NGSI LD format. But there are other components in order to secure the context broker, that is basically via Keyrock and Kong, for example. These are all provided by FIWARE as compliant iShare components. Then you have the identity provider, which is a Keyrock element or component, again complying with iShare specifications. There is a marketplace, FIWARE marketplace component, which we will learn more about in a bit in the next session. And the authorizations provider, which is based on the authorization registry role of iShare. Again, the Keyrock component here is made compliant with that specifications. I have included this slide as an example of how participants are mapped to a role model. This example is what you will see later in this session, where we explain with this example how various elements of i4Trust are utilized. So just to give you an highlight in terms of the different organizations you can see are mentioned near to the role. So they are actually playing their own, playing different roles, or multiple roles within the example, and depending on the use case you are in, you have to look at this organization playing that specific role, right? So No Cheaper and Happy Pets are data consumer, but they are also data owners. Packet Delivery Company is data provider as well as data owner, and each of them brings their own identity provider as well as authorizations provider. And in the example, the marketplace is provided by iFortrust Marketplace instance, but experiments or other parties can implement their own marketplace, or data spaces can implement their own marketplace. A trust provider is basically based on iShare satellite. So an fictive organization called Trust Foundation is running this iShare satellite within this data space, for example. So I already explained these roles, but a brief recap in some of the highlighted roles is trust provider is basically the one which facilitates trust in data space. And many times it is also the organization which is responsible governing body of a data space. However, it is the one which maintains the level of trust in the data space by following the rules of that is defined for a data space, which all participants are expected to follow. So they enforce those rules at the participants by various means like auditing or regularly updating participants' information in the database and other things, right? Identity provider, and as I've already explained, in this sense, Keyrock is the component which you can deploy and run as an identity provider. Remember that just running Keyrock doesn't make you an identity provider, which you can register officially in the production of iShare. For that, you also need to comply with organizational requirements, and you need to sign certified identity provider agreement, which has certain organizational requirements as an identity provider, right? Similarly, for authorizations provider, um, Keyrock as an open source component is made available as a technical component which you can use to become an authorizations provider or authorization registry provider. However, as an organization, there are certain additional requirements apart from technical requirements that you need to fulfill, and these are assessed during the admission process. And if you would like to learn more about them specifically, if you are interested in playing any of these roles as an independent authorization registry provider or identity provider, please do get in touch with us and we can explain to you those roles further, those requirements further. However, they can also be found on iShare website via the admission process. Yeah. And last but not least, in this sense, recapping the 12 building blocks of i4Trust, which act as boilerplate for creating your data spaces, the four verticals, and as you can see with the logos on each of those blocks, these are provided to you with FIWARE and iShare, which explains which gets you quickly started in making your own data space. That is it from my side today. I hope you enjoyed the session, and with this, I will pass on towards the next session that will be conducted by Francisco for i4Trust Marketplace. I'm not sure if you would like to take a break in between, but I leave it to Francisco.
Okay.
I'll stop sharing my screen. Yes.
Oh, okay, I hope you can see my presentation properly. Well, thank you all for attending. In this second part of the session that we are having today, we are going to have a look at the i4Trust Marketplace, and we are going to, this is the agenda that we are going to follow. We are going to start having a look at the Business API ecosystem generic enabler, which is the FIWARE component that is used that has been used to create this i4Trust Marketplace. We are going to review some of the main concepts that we have in the Business API ecosystem. And then I'm going to show you how we have used the Business API ecosystem in order to create this i4Trust Marketplace. Okay, first of all, let's start with the Business API ecosystem. The Business API ecosystem is a FIWARE generic enabler, which is providing the tools that you need in order to create a marketplace for the monetization of digital assets. The idea with this component is that it is providing all you need in order to manage the life cycle of the product offerings. Since the service registration and the product creation, to the monetization, to the billing, it manages the payments and also manages revenue sharing in those scenarios where there are multiple stakeholders involved in a specific offer. In addition to this, the Business API ecosystem is fully integrated with the FIWARE identity management framework, as well as the iSHARE framework that has been presented and different identity managers, as we are going to see later. And the most important point regarding the Business API ecosystem is that this software is exposing all the functionality that is providing using a set of standard APIs that has been defined by TM Forum organization. We are talking about catalog management APIs in order to create products, offers, catalogs, etc. We are talking billing management APIs, order management API for purchases, also usage for those scenarios where we have pay-per-use, etc. Okay. In addition to this, the Business API Ecosystem Generic Enabler, as I said, is a software that is intended so you can create your own marketplace. So it's highly customizable. You can create your own themes, you can provide your branding, you can provide your own look and feel, etc. So you can modify it in order to feel with your organization branding, and is integrated with multiple identity providers. So you can choose the one that is better for your needs. Of course, this software is integrated with FIWARE Keyrock because it's the identity manager we are providing as part of the FIWARE ecosystem. But this is also integrated with Keycloak, which is an identity manager provided by Red Hat. And if you have a use case where you don't need a lot of complexity and you only need login and these kind of things, it is also integrated with GitHub accounts. So you can use GitHub in order to sign in into the Business API ecosystem software. Well, as I mentioned, this software is intended to create monetize any kind of digital asset. But how is this achieved in reality? The idea with the Business API ecosystem is that the software is managing those functionalities that are common in any marketplace scenario. That's it. Service registration, offering creation, offering publication, offering discovery, monetization, payment, it's managed the orders, it has some stuff for activation, etc. All the functionality that is common in any marketplace scenario is managed by the Business API ecosystem software. Then, all that functionality that is particular to the specific digital asset that you want to monetize is something that is included in the Business API ecosystem by providing extensions. The Business API ecosystem defines a format, is Python code. It is defined a set of handlers that are triggered during the life cycle of an offer, when a product is created, when an offer is created, when a service is acquired, etc. During the life cycle, some triggers are triggered, and then in this extension implements implement the different handlers. The idea here is if the kind of product you are creating is something as like an Android application, for example, that you are uploading, after creating the product, what you will need to do is validate that that file that you have uploaded is actually an Android bundle. But in a completely different scenario where you are monetizing some kind of API which is secure with some kind of security framework, the validation that you have to do is completely different. You have to validate that the user has permissions, that the API you are providing really exists, etc. It's quite different. And it's similar when we are talking about activation. It's not the same activating something that is in an environment where the security is provided by roles than activating something where the access is managed with this iSHARE framework and these policies that are created into an authorization registry. There are completely different scenarios. So these particularities are implemented as part of these extensions. Each extension defines a specific digital asset type, and then when you are registering a product, you can choose which is the digital asset type you want to sell, and then you will be asked to provide whatever metadata is needed in that specific scenario. The final thing I have to mention about this is that you are not limited to URLs. When you register a product, this might be something registered as a URL, but it also may be files that you can upload into the marketplace, etc. So there are no restrictions in this regard. Okay, the Business API ecosystem is currently supporting multiple price models. Since the most simple one, which is the typical free offers, to some stuff a little bit more complex. Regarding the free models, the business ecosystem is supporting two different kinds of free models, which is, on the one hand, we have free models, which means that you have to buy the offer. It's free, but you have to buy the offer, you have to accept the terms and conditions, basically creating an order and follow the whole ordering process in order to get access to the service you are buying. And there are also the possibility of defining open offers. Open offers are those offers that does not need to be bought in order to access to the resource. This is typically used in scenarios or use cases when we have things like open data, where you have the open data, you don't even need to register. This is there. So you can create an open offer for this, and then it is possible to access to the specific asset directly. When we are talking about the paid price models, the business API ecosystem is supporting three main basic price models. On the one hand, we have one-time payments, or that are, typical, you pay the price and you get the offer. It's simple one. Then we have subscriptions, which are the typical recurring model. You pay per month, you pay per year, you pay per quarter, etc. And the business API ecosystem software is also supporting pay-per-use, which means that you are going to pay for the actual usage you are making of the offer that you have bought. In addition to these three basic models, these three basic models can be enriched with some advanced functionality that allows you to create dynamic and more rich price models. For example, it is possible to add fees and add other price models. For example, if you have a pay-per-use model, you can add a one-time payment, an initial payment. So when you buy, you pay one time, and then the rest of the consumption of the service, you are going to be charged in a pay-per-use basis, for example. Or you can create some dynamic stuff. You may have pay-per-use model, and you can create a discount. For example, if the user makes more than 10,000 calls during the charging period, for example, during a month, you are going to give him a 2% discount in the final invoice. For example, these are the kind of models that can be created with this software. Okay, as part of the different offers that you can register in the business ecosystem, you can provide the terms and conditions. This software is giving you different ways of providing these terms and conditions. In data-specific environments, on data-specific use cases, the business ecosystem has built in a couple of typical data licenses you can choose. If not, it is providing some kind of wizard that you can use if you want to use it in order to create your terms and conditions. And if any of this is okay for you, you can always provide your own terms and conditions, writing them down. A fully custom license, and you can provide it. And it is also possible when you are creating an offer in the business API ecosystem to specify different kind of service level agreements that are to be satisfied. Okay, and the final important feature that we have in the business API ecosystem is the support for the revenue sharing models. If you have a scenario where there are multiple providers involved in the monetization of a specific offer, it is possible to create these revenue sharing models. These revenue sharing models establish how the incomes generated by a set of offers must be distributed among the different stakeholders. It's basically you have to provide which percentage of the total incomes are going to be retrieved by the provider, the one creating the offer in the marketplace, and which provider is going to be sent to the different stakeholders involved in the offer. In addition to this, the business ecosystem is supporting something which is called the platform percentage. When you are creating a revenue sharing model, you will see that there is something fixed, which is this platform percentage. This is a percentage that is given by configuration of the marketplace instance and is intended to those use cases where the marketplace provider, the one that is deploying the software of the marketplace, wants to get some percentage of all the transactions that are executed in this marketplace. Okay, if there is a platform percentage defined, when you create a revenue sharing model, you have to take into account that this is something that you cannot change. This, of course, this platform percentage can be 0. If the scenario, if the business model of the marketplace provider does not include this kind of payment, the platform percentage can be set to 0, and then we can let the different providers to define their own revenue sharing models. Okay. Okay, so now I'm going to go a little bit deeper in some of the business API ecosystem concepts, mainly on those that are related to objects that are managed by the TM Forum APIs. Okay. Well, first of all, the business API ecosystem is managing different elements that allows you to classify your products and allow that your products can be searched and easily discovered. Those objects are taken from the TM Forum Catalog Management API and are two different kind of objects. On the one hand, we have categories. The categories are created by the system administrator. So all the providers in the system are going to have the same category list. And when you create your offer, you are able to choose in what categories your offer is. The idea is that when you access to the marketplace page, you are able to search by category, and well, you can group the offers by category and discover what are better for you. In addition to this, there is another way of classifying the different offers published in the system, which are the catalogs. The catalogs are created by the providers themselves. So the provider can create different catalogs in order to group their own offers. The catalog can be used in order to search by catalog in a similar way as it is done by category, but just that the catalogs are created by the providers. An important note here is that all the offers in the system need to be part of a catalog. So at least you are going to have one catalog per provider. Okay, in addition to this product classification of elements, the TM Forum Catalog Management API is providing everything that is related with the product creation. So, well, we have on the one hand, we have to know which is the asset. This asset is not part of the TM Forum. This is the asset is the real digital product that you are going to register in the system. That's it, the data, the file, the service, and its metadata. And then the objects managed by the TM Forum are the product specification and the product offering. The product specification is the definition of all the product-related information linked to the specific asset. That means the information of the asset, which are the product characteristics, which are the different attachments that you have in the system, that you have for the product, for example, pictures, documentation, or whatever. Everything that is related with the product is defined as part of a product specification. And then we have the product offering, which a product offering is linked with a product specification and define all the business related information that is linked to a specific product specification. So it includes a link to the catalog where it is published, a link to the product specification that is going to be published, and then includes the license and the terms and conditions, the service level agreement that is applying to this product offering, the pricing model that is going to be applied to this offering, the different terms, and also the revenue sharing model that is going to be applied to this specific offer. An interesting point with the product specification and the product offerings is that you can define bundles in the business API ecosystem. So, for example, you can create two different offers offering two different products, and each of these offers may have their own price model. You can create a product offering bundle when you are selling these two product offers, and there, for example, a better pricing model. You can add some kind of discount if you buy all this stuff together, for example. These are different models that can be done using this API. Okay, another very important element within the business API ecosystem APIs is the usage. As I have mentioned before, the the business API ecosystem software is supporting pay-per-use. But in order to be able to process a real payment and a real offer that is under a pay-per-use model, you need the accounting information, you need the usage information. Okay? This is where the TM Forum Usage Management API is used. We have on the one hand something which is called the usage specification. The usage specification is an object that is used in order to define a type of user. So in a usage specification, you specify which are the units and which are the metrics that are going to be monitored for a specific offer or group of offers. Okay, if you have multiple offers as a provider that has the same kind of monitoring and the same kind of metrics, you can use the same usage specification to all of them. And then we have the usage document, which is the actual usage that has been made of a specific product specification asset during a specific period of time. Basically, the usage is this object, the usage document, also includes it's associated with the price. So when this usage document is uploaded into the system and the business API ecosystem calculates the amount of money relative to this specific usage document, that information is also placed as part of the usage document. So you can see together the actual consumption and also the price associated to that actual consumption. And well, this usage document also establishes or also specified whether this money has been charged or not from the user. One interesting point regarding the usage is that the business API ecosystem software is supporting two different ways of providing this information in the system. Because if you have some kind of service that you want to sell under a pay-per-use model, you need to monitor the usage of the service. So as a data provider, there are two ways of providing this information in the business API ecosystem. The simplest one, you can push your accounting information. You can create the usage document and push that usage information and push that usage documents directly using the TM Forum Usage Management API, which is an API of the business ecosystem. You can just push the data. But we are also supporting something which is the pull mode. As I mentioned before, when you sell some kind of digital asset, you have created an extension for it, a plugin that is loaded into the business API ecosystem. As I have mentioned before, there are a couple of handlers that you can implement in order to manage the lifecycle of your offers. Okay. As part of those handlers, there is a handler that is intended to generate these usage documents, which is the pull mode. You can develop a client for your accounting system, just in case your accounting system has an API or something like that. You can develop a client for your accounting system, place this client for your accounting system in this handler of the different extensions of the business API ecosystem, and then when periodically the business API ecosystem is going to access your accounting software and is going to automatically generate the different usage documents that are then used in order to charge the different users. Okay. Okay, and well, the final concepts I want to show you are the ones related with the revenue sharing. First of all, when we are playing with this revenue sharing, where you are going to have are the different revenue sharing models. As I have mentioned before, a revenue sharing model established how the money generated by a set of offerings has to be distributed among the different stakeholders that are involved in those set of offers. So basically, as I have mentioned before, this includes the platform percentage, the provider percentage, and a list with all the stakeholders and the percentage that each stakeholder is going to receive. You run these revenue sharing models to the different offers, and every time an offer is bought, what is going to be loaded in the system is a transaction. A transaction is a payment that has been made by the different customers, which is linked to a specific revenue sharing model. Each transaction is linked to a particular revenue sharing model. So we have the revenue sharing models and we have the transactions. The last thing that we are going to have is the revenue sharing report, which is the result of applying a revenue sharing model to all its linked transactions. It's basically going to sum up all the money, is going to calculate how much money has to be sent to the provider and how much money has to be sent to the stakeholders. And this information is part of the revenue sharing report. And that's it. Okay, those are the main concepts that we have around the business API ecosystem software generic enabler as a general generic enabler used in order to create different marketplaces. And now we are going to see how we have used the business API ecosystem software in order to generate this i4Trust marketplace. Okay, well, the first thing that we have done in i4Trust in order to create this i4Trust marketplace is integrating the marketplace with iSHARE protocol. So the idea is that you can have an i4Trust marketplace instance, and there might be multiple organizations, the different participants in the data space, and each organization may have their own identity provider, as has been previously explained. So each participant in the data space has their own identity provider, and the idea is that when they want to log in into the marketplace, they don't want to log with an identity provider that belongs to the i4Trust owner. They want to log using their own identity provider. So thanks to this integration that we have done of the marketplace with the iSHARE framework, this is feasible. You access to the marketplace, and then you click on login. You are going to be prompted with all the different identity providers of the different participants that are part of the system, and then you are able to log in the system using your own credentials in your own identity provider. This is done following the iSHARE protocol and using the iSHARE JSON Web Token in order to authenticate the marketplace in the different IDPs. With this approach, it is also possible that you, as a participant in the data space, you have your own context broker, you have your own identity provider and your own security framework. Your data is in your organization, but you can sell your data or whatever service you have in your organization through this marketplace, even if you are not the owner of the marketplace. Okay. Well, this is more or less the scenario. I'm not going to go very deep on this because this scenario is going to be presented later in the demo, and also Rajiv has gone regarding on how all this stuff is working. But here you can see the thing. We have the marketplace, we have different organizations, different participants in the data space, and all of them can use the marketplace and log in the marketplace using their own identity provider and their own identities. How is this working? Well, as I mentioned, you access the marketplace, you select your identity provider. The marketplace is going to generate an iSHARE JSON Web Token, as has been explained before, signed with the marketplace participant digital certificate, and is going to send it to the identity provider, to the identity provider that has been chosen in the list. The identity provider is going to use this JSON Web Token in order to validate that the marketplace is a valid participant on the data space through the trust provider or the iSHARE satellite component in particular. This is going to return us a login URL, and then as you have this, the flow is as a typical OpenID Connect flow. You got an authorization code that you exchange by an access token. I don't want to go very deep on this because this has been already presented. Okay, so now we have our i4Trust marketplace integrated with the iSHARE protocol, so you can use your identity. Well, if you want to sell some data that you have in a context broker that is under your organization and is part of your architecture as a participant, in order to do that, we have created an extension. As I mentioned, all the digital assets in the marketplace are monetized as extension. So in order to sell this kind of data, we have created a plugin for i4Trust. It's a plugin for i4Trust that basically allows you to provide all the metadata that is needed to the policy that is going to be applied to the customer when they buy. Okay, so when the product is created, the information is validated, all the stuff is validated, and when the offer is acquired, the marketplace is going to create the specific policy with the data in the specific authorization registry that has been created, that has been provided. And well, that's it from my side. Okay, so I think that the next one presenting might be you, Dennis.
Yes.
Yeah. Just a thought before you start, Dennis. If are there any questions so far for either of the sessions, for iShare or for the marketplace? Okay, I see one question. Which information of data asset sharing is anchored, stored, and verified in blockchain? How we get this information? Not sure which information are you talking about, and which blockchain are you talking about? Sorry.
Yep. Is it possible to support scenarios such as authorize a user if she has bought something from the marketplace? Yes.
That's what you will see now at the presentation from Dennis.
Yes, this is what Dennis is going to show.
Okay. So maybe it's too good to be true looking for it. Yeah, you will see. Yeah, so let's continue with the session, and please feel free to put your questions in the chat. I'm monitoring the chat as well, so I can answer them. And of course, at the end of the session, we can again open the floor for questions. Yes. So with that, Dennis, you may continue.
Okay, thank you. So my name is Dennis Wendland from FIWARE, and together with my colleague Stefan Wiedemann, we will present the final presentation where we now put all of the things together which you have seen in the past days of this i4Trust training. And this we will do using a reference example, which I will give an overview in the beginning, give some prerequisites that are needed, and then we will start with the first demonstration where you can see all of this in action, using the flows also described by Rajiv today, and then giving a description of what's actually happening technically. And then Stefan will take over with another demonstration with another flow using verifiable credentials, and also explaining about the technical details. And finally, we give some hints on how to set up all of these components. So let me start with the reference example. So this is a use case which we use to showcase how all of these things can be put together. And in general, what we want to show is how to delegate the access rights for a certain data service within the trusted data space. And these should be delegated from an organizational to a user level, where the actual service providers will not need to have any knowledge about the actual users which finally will access the service. There are different parties involved in our data space here, which you can also see on this diagram. There's a packet delivery company offering delivery order services. These services are offered on a marketplace, instance in our data space. There are different retailers that will acquire access to the service offering, and these retailers will delegate these access rights to their customers. And what's also required is a trustless authority within the data space, which is actually the iSHARE satellite, which ensures trust among the different organizations. Now, this packet delivery company is a typical delivery company for packets, and it provides a digital service for its delivery orders. And in general, a delivery order is now mapped as a digital twin. So it's an entity in a context broker which will reside within the environment of this packet delivery company. And these entities are characterized by certain attributes like an issuer or an destiny of the packets, an origin or delivery addresses, and also planned dates and times of the arrival of the packets, and also an estimated date and time of arrival, just for an example. And this digital service is offered on different levels. There's a standard level, which only provides read access to these delivery orders on the digital service, and there's a gold service, which will also allow to change certain attributes, like, for instance, the planned time of arrival. So there will be two different offerings on the marketplace, which can be acquired by these different retailer organizations. And depending on which offering they acquire, they can allow now then their users either only to have read access to these delivery orders to view when there's, for instance, when the packet is planned to arrive, or even allow them to change the planned time of arrival. So these retailers, as I said, will acquire these offerings and offer these to their customers. This means basically if a customer would now order something on these shops, there will be a delivery order created so that there's a packet to be delivered, and then these customers can directly access this digital service of this packet delivery company, either with read or also with write access, depending on the required service offering. Now, for the demonstration and the setup, some prerequisites so that we know what's going on. Just giving an overview of the actual architecture of these different organizations in our data place. So on the one hand, we have the marketplace, which we have also learned from Francisco now, which is based on the business API ecosystem. We have this organization of the packet delivery company, where we have different components, especially the context broker, of course, where the actual delivery order entities are stored. There's an IDP, which is used for login purposes, as also presented. For instance, when such employee of this packet delivery company would like to log in on the marketplace to create offerings, for instance, there is a portal application, which is just a simple graphical user interface for the users that wants to access the service. PEP and PDP component, which control and manage the access to the context broker. So which actually provides, this PEP actually provides then the actual endpoint, exposes it to the outside, and an instance of the Authorization Registry where access policies are stored. Then the environments of the different retailer shops are similar. There will be some shop system, of course, where customers can order things, and then there are also instances of identity providers, which for instance, that users or customers can also log in, and also they have their own authorization registries where they store their policies on the user level, so policies where they delegate access rights to the users. And then there's the iSHARE satellite as trust authority in the data space. The marketplace, I think I can go over this quickly. Francisco already introduced it, consists of several subcomponents, requires some databases, MongoDB and a MySQL database, for the different components. There's a component implementing the different TM Forum APIs, which is interacting with the MySQL database. There are components for charging backend, which is relevant for the charging and billing of offerings. There's a component called RSS, which is for the revenue settlement and sharing, and a logic proxy, which fulfills, on the one hand, the role of the actual UI interface of the marketplace, and also as an API orchestrator for the different components. Then the trust authority. We are using here the iSHARE satellite. There is a test instance available provided by iSHARE. There, each of these organizations in our use case are all registered with their own EORI IDs. So there's a registration for the marketplace, for the packet delivery company, for these two retailers, Happy Pets and No Cheaper, which is what we call them here. And of course, the iSHARE satellite itself also has some such ID. And using the satellite, within each interaction, every participant in the data space can all the time verify the status of each other organization. Now, the shops. So in this demonstration of our reference example, we of course focus on the actual data exchange, also with the packet delivery company. So actually there will be no shop system. So we will just assume that there was already some customer which ordered something on the shop, and therefore there is already a pre-existing entity on the context broker as packet delivery company representing the actual delivery order. We have two identity providers actually. One is reserved for the company employees of this Happy Pets shop itself, which allows them, for instance, to log in on the marketplace to acquire the service offering of packet delivery company. And there's a second one for the customers, which they on the one hand would use to log in on the actual shop system of Happy Pets, but can also use to log in, for instance, in later on the portal of the packet delivery company, using the processes explained by Rajiv. As I said, there's an authorization registry where we already created a policy which states that certain customer of Happy Pets is allowed to perform requests on entities of type delivery order, and he can perform GET requests and patch requests. So these are the actual HTTP methods, also of the context broker. And for the patch, it's only allowed to modify the attributes called PTA and PDA, so the planned time and date of arrival. So in this case, Happy Pets will be an organization that will acquire the premium offering of packet delivery company, so which allows them to delegate these access rights later on to their customers. But this is an pre-existing policy here now for the actual users. Similar for No Cheaper, there we say, okay, this will be an organization that will acquire the standard offering, only allowing read access. So they will create access policies in their own authorization registry, delegating only these policies with GET access rights to their users, for also accessing entities of type delivery order at this packet delivery company service. Then packet delivery company, as I said, there's a portal application. We have some simple demo application available, but which is really only dedicated for this specific reference example here. But this implements all the different flows relevant for the use case. The identity provider is actually only used for this employee of packet delivery company, so that he can log in on the marketplace and create the offerings for their digital service. And of course, there's an instance of the context broker which provides the NGS ILD API for reading and changing entities of the type of delivery order. And now also for this reference example, since we assume the customer already ordered something on the retailers and there's already a delivery order created, the initial delivery order needs to be created manually. It's something we already done. This is how this could look like. So typical entity in the context broker with a type of delivery order and certain attributes here. Then there's an PEP and PDP components. This is where we use Kong with a certain plugin which is performing the access management according to iSHARE for NGSI LD requests. Then there's an instance of the Authorization Registry, which holds the organizational access policies. So at the moment, there are none of them. But as soon as now an employee of these retailer shops would acquire an offering on the marketplace, there would be certain policies created which state that the organization actually has access to the service and can delegate these access rights to the customers. In addition, there's an activation service in front of the Authorization Registry. There's also a simple implementation available. This is actually only required that the marketplace is actually able to create policies at the registry of the packet delivery company, because normally you only the owner can create policies which state, okay, the issuer, for instance, packet delivery company, gives access rights to a certain access subject. Only packet delivery company could create such policy. So we place this activation service in front. So there's an additional policy required which states that within this packet delivery company authorization registry that the marketplace will be allowed to create delegation evidences. So after this point, when this policy was created, the marketplace is able to create policies here on behalf of packet delivery company in their own authorization registry. Now let's come to the demonstration. So what I'm skipping now is the part of the creation of an offering, because we have seen it in Francisco's presentation. So as you can see, there are already some, and there's especially this basic premium offering of packet delivery company. So now we assume an employee of this packet delivery company created these offerings. And now let's assume I'm now an employee of this Happy Pets retailer shop, so some administrative user. So I want to log in on the marketplace. So I'm listed now the different IDPs in our data space. I'm selecting the one from my own organization, which is Happy Pets, selecting sign in. So now I'm forwarded to the IDP, which is in this case Keyrock, of the Happy Pets company, and log in as this employee user. So now, since Happy Pets wants to acquire this premium offering, I can have a look here. There's some description, and in the characteristics, I see, okay, it's an NGS ILD data service, which is offered here. I see the endpoint with the URL, and I can see, okay, I will be able to access entities of type delivery order. I will get permission to perform patch requests for the attributes of PTA and PDA of the entities, and get access rights for all the attributes. So there's a wildcard here. Now, before I acquire the service offering, let me first show you that actually the access currently is not working, of course, so that this is all real happening here. So let's have a quick look at this actual portal of the packet delivery company. Now let's switch roles. I'm a customer of Happy Pets, and similar to the marketplace, I'm offered different identity providers for login. So since I'm customer of Happy Pets, I'm choosing this one. I will log in as a customer of Happy Pets. Now what I will try is to read the values of a certain delivery order entity, a packet delivery company which has a certain ID here. I'm hitting the button, and now from the PEP and PDP, I'm getting an error message back that actually there's no policy authorizing this access. So just showing actually it's not working. But now switching back to the marketplace, I'm now an employee of Happy Pets. I will review this again, add it to my cart, perform the checkout. We now have not put no price plan on it, but basically this could be some price plan, for instance. But so now what happened now that the marketplace created a policy. It's a registry of packet delivery company, which states that from now on Happy Pets is allowed to delegate access rights to their customers. So now let's try again. I'm still logged in as this customer of Happy Pets. I'm retrieving the delivery order, and now I'm getting the response from the context broker. Pretty simple here with the different attributes. And since Happy Pets acquired the premium service offering, I can even perform the patch operations. So let's say I want to get my package rather in the evening. So I'm hitting change. What will happen now is that this application will send now a patch request to the PEP of packet delivery company, which again checks the permissions and then forwards the request to the context broker. Afterwards, we'll retrieve the changed delivery order again, and now as you can see, the planned time of arrival has changed. Okay, maybe for a second example, now for this No Cheaper, I will sign in again now as an employee of the No Cheaper organization. So now I'm forwarded to a different IDP from this No Cheaper organization and log in as employee user. Now for No Cheaper, they are only interested in this basic offering, which only allows read access. It's also seen here in the characteristics. So there are no patch permissions. Adding this to my cart and performing the checkout. So, and now on the portal, I'm logging in now as a customer of No Cheaper. So I'm choosing their IDP. And now I'm customer of them, now trying to retrieve a certain delivery order, which works, of course, since I have the get permission. But now when I try to change the planned time of arrival and let's say to retrieve it in the morning, it states that the user policy is not authorized. And what we even can try now is a second example. I need to log out here because I have a second user registered at No Cheaper, which is called the GT customer, because this customer actually has in the registry of No Cheaper, there's a policy stating that this user can perform get and patch, but still the organization No Cheaper itself is not allowed to delegate these patch access rights. So what will happen now when this guy retrieves the delivery order, it will of course work because the user policy states he can perform GET requests and the organizational policy of No Cheaper states it can perform GET requests. But now if the user also tries now to change, also to send a patch request, this is also denied, but this time not because of that the user's policy doesn't allow it, but just because the policy of the organization, which was issued to the No Cheaper organization, doesn't allow to perform these patch requests. So that's basically the demonstration of all of it. And so coming back to the presentation, to have a look now what actually happened in the background. I didn't show how to create an offering because it's also rather simple, and we have seen it in the Francisco's presentation. There's basically just some interactions when this employee logs in at the marketplace, chooses the IDP of the packet delivery company, Here's a login based on the OpenID Connect standard. There's an interaction of the IDP with the satellite, whether this marketplace is a trusted party of the data space, and when he's logged in, he would create the offering and provide all the information, which we have also seen in the product characteristics on the marketplace. Now, when the acquisition took place, there's a bit more happening. So what we've seen, I logged in as an employee of Happy Pets on the marketplace. I've chosen the IDP of Happy Pets. There again was an interaction with the satellite, whether the marketplace is a trusted party. When the login was done, this employee selected this premium offering and performed the checkout. And what then happens is that the marketplace, particularly the charging backend component, is it actually, will create the access policy for the Happy Pets organization at the registry of packet delivery company. So which looks like this, stating, okay, the organization of packet delivery companies issuing this policy to the organization of Happy Pets, stating these patch and get permissions for delivery orders, and is creating this at the Authorization Registry. And as I said before, this is not directly sent to the registry, but rather to the activation service in front, because otherwise the marketplace wouldn't be allowed to create such policy actually. For No Cheaper, it works similarly, but just that the policy that was created doesn't contain this patch permissions. And now when accessing the service, I was this customer, so entered this portal of the packet delivery company, also chose the IDP, which in this case was the IDP of the Happy Pets company. And after login, I requested details about a particular delivery order and performed this patch operation. So what's happening is that during the login process, the IDP will issue a JSON Web Token, which will contain the policies of the actual user, because these are stored here in the Authorization Registry, and these will have substructure here, so stating that the Happy Pets organization is issuing to a certain user this access policy, and this is contained in the access token. And when he issues now a request using the portal to the PEP of packet delivery company, there will be a verification of the JSON Web Tokens, because these are signed, of course, with the private key of Happy Pets. And then there's a check, of course, if the policy allows the certain operations, so for instance, performing the patch request. And there's another check at the registry of packet delivery company, whether actually Happy Pets is allowed to delegate such access rights. And if both of these policies are fine, as we can see here, access is granted. So basically the PDP will perform two checks. On the one hand, is there such policy issued by packet delivery company to Happy Pets, and is there such policy issued by Happy Pets to the customer, so that you have a chain of these delegation of this access rights for accessing the service. In the scenario of No Cheaper, actually it's basically the same, but just the different policies missing these patch permissions. Another scenario that I at least want to mention, I didn't show it now, but it's also possible because now we focused on these human-to-machine interactions where human identities are involved. Of course, similar mechanisms also work with machine-to-machine interactions. Rajiv has already explained that earlier. Basically, possible use case, it's not implemented now, but what one could think of is that the actual creation of a delivery order, when the customer is ordering something on the retailer online shop, that shop system will create the delivery order at the packet delivery company. So that would be, for instance, a purely machine-to-machine interaction where the shop system would directly create the delivery order, This would require an additional offering to be placed on the marketplace, which also such retailerships could acquire. And there would be also policies issued to the retailer organizations allowing them post requests to actually initially create entities of type delivery order. In this case, no humans are involved. And in this case, the flow is pictured here. So in this case, the shop system would directly create a signed JSON web token, as explained also by Rajiv, signed with their own private key, which allows to identify, and would request an access token at the packet delivery company. The IDP keylog is able to issue such access tokens for the machine-to-machine interactions. In this case, also Happy Pets would be checked against the satellite as a trusted party, and then an access token would be returned. And then the shop system could send a post request together with the access token to the PEP with the NGS ILD request to create a delivery order. Then again, the PDP would check against the registry whether Happy Pets actually allowed to perform these post operations to create entities, and then this request would be forwarded. So basically similar, but only with the difference that there's no human involved, and basically no the IDP is not required for users to log in this case. Here showing so some more details. So this is how such request would look like to obtain the access token at the endpoint of packet delivery company with a machine-to-machine flow in iSHARE. This would be the information of this access token, which is issued by the packet delivery company to the Happy Pets organization. And then when the NGS ILD request is sent, there would be checked against such policies, which would be required to perform this operation. Okay, then I would hand over now to my colleague Stefan to perform the next demonstration about a different flow of these interactions. And yeah, Stefan can give you more details about it.
Yeah, thank you. Hello, my name is Stefan Wiedemann, also from the FIWARE Foundation. And I will now basically present you the, let's say, next evolution of this framework, where we will also incorporate the usage of verifiable credentials for authorization. So some of you might have already heard of the flows or of the protocols OIDC for VP or SIP2. And I will now show you how to put this actually in work in this, in our i4Trust framework. I will not go into too much details of the of what a verifiable credential is. I hope you did see the presentation from Ruiz last week. Let's focus on questions about this after the presentation. Okay, let's start with the demo. As you probably have seen in the packet delivery portal when Dennis opened it, we not only have the options to choose the IDP that we want to log in, but there's also the login with verifiable credentials button here. To log in with a verifiable credential, we have to set up different stuff in the marketplace, and I will start with exactly that. So the marketplace is now, you're now already familiar with the marketplace from Dennis and Francisco. And Francisco already presented you that we need to set up the IDPs of the participants in our marketplace. If you want to use verifiable credentials, we don't have this need to have IDPs in the same way anymore, but we need to register our users as issuers of verifiable credentials. That's why there is now a new field within the IDP configuration here, where you can set insert the issuer ID from your participant. In the future, when you also can use the verifiable credentials to log into the marketplace, this is not needed at all anymore, because the issuer ID then can be retrieved from the used verifiable credential by the participant of the marketplace. But for now, where we still log in with the old flow into the marketplace, we have to set the issuer ID here so that it can be used for setting up all the required policies to verify and authorize the credential in the next steps. Okay, so I already prepared the issuer ID for Happy Pets and the issuer ID for No Cheaper, so that we now can create an offering that both of them can buy. I will sign again in as packet delivery, and I will actually create a specification and an offering because there is quite a difference to what we already know from the plugin that Francisco showed us. I already prepared one for the standard service. You can see here that it has less, let's say, less fields than the other one. The most notable differences is that you have to define the verifiable credential type that a service supports and the roles that a buyer of the service is allowed to issue. I already defined the standard service, and I will now start to define an additional service for, let's say, for premium customers. Basically the same that Dennis had also with his premium service, where a user is allowed to change, let's say, the planned time of arrival of a packet of a delivery. Call it packet delivery premium service. I will go fast through those parts. We now have another an asset type here, which is the NGSILD data service for verifiable credentials 2. This is the one that now brings us the other form. You can see here that all the fields about the HTTP calls and what you can do with the actual request are not in here anymore. But we now can set a list of roles that a user or a service is allowed to issue. Those roles have to be pre-created in the policy, in the Authorization Registry of the data provider. In our case, this would be packet delivery. And then we are defining here only what roles a data consumer is allowed to issue to its users. So I will fill out this quickly. Most of the early fields are basically exactly the same. You already know them. So let's quickly go through them. Make this run only for a certain amount of time. We now tell that we allow the issuing of credentials of the type packet delivery service. And we tell it that gold customers and standard customers are allowed to be issued. We can go further. We can upload a picture, but we don't need to. We now have to launch the service and create an offering that we then can acquire. We have to use the product spec that I created right now. We put it to our marketplace. I skipped the price plan because that's really not the topic of this presentation. And I will launch the offering. So now we will have on the marketplace available this new offering, if we go here, which is the packet delivery premium service. When I now buy this service as Happy Pets, let's go to the market and buy this. I can see here that those are the roles that are supported, that this is the packet delivery service credential that is supported. This is the checkout process that you already know. Now there is a policy created within the packet delivery service authorization registry that allows us to assign those credentials. To log in here now with login verifiable credentials, we need a verifiable credential that we then can present basically through the OpenID for verified presentation flow to our portal. To do so, we now have to go to the verifiable credentials issuer of Happy Pets, which is an application. Okay, I already have a couple of credentials here. But this is basically the application that the employee of Happy Pets will use to create a verifiable credential that it then can issue to its customers. And the customer can use it to log into the system then. I will now create such credential. The email address, well, let's call it happy customer. We have the first name and the last name. Then we have to define the target entity that we want to use, that we do issue this credential for. This is important for the credential, because a credential can basically be used in different contexts. What we say here is we want that the role that we assign, it's the old customer role, belongs to a packet delivery. If the customer uses the same credential in a different context, for example, if he also wants to access the Happy Pets shop with it, Happy Pets might have different roles. It would then also add an entry with the entity ID of Happy Pets and the role that belongs to Happy Pets. We can see that better in the JSON representation of the verifiable credential here, because that's basically part of the credential subject. I might make this a bit bigger, because the subject now holds a set of roles that can be evaluated by the PDP later. The role that we did set here is the role gold customer in the target packet delivery. We can set multiple roles within one target, so we could also add the standard service here, or whatever we else want. But we also can add additional entries here. And if we then send this credential to, let's say, Happy Pets, this part will be ignored and only the roles targeting Happy Pets will be used. Okay, that's our credential now. And now we have to basically offer it to our user. We can do this with this application easily by scanning the QR code with our wallet. I have a small wallet application on my mobile phone. So let me scan this. You can see this here. Let's see. Okay, so I now have the credential on my phone. I can save it. And then I can go to the login, where we have it here, and scan this QR code here with my wallet. Again. There. And now the wallet asks me to send the credential. And when I click on send, we will now be redirected to the actual service. Because in the backend, the verifiable credential is now validated and exchanged to a JWT token that is then used by the portal application to connect through Kong with its downstream services. What I can do here now is basically exactly the same that Dennis showed you. Actually, we can see now here that we are logged in as happy customer, which was the name I added in the credential. When I now also do get on the Happy Pets, I get my delivery order, and I can also change this because I'm a gold customer. Oh, nice. So I also bought the access for No Cheaper for the standard service before the presentation to basically save some time. So we can also check that when we now log in through the same mechanism as a customer of No Cheaper, we have to go again to the No Cheaper credentials issuer. If we would have more time, this is also something that could be done by some of you, but I think we're running out of time if we do this. I give it another name so that we can differentiate them. Again, packet delivery and the role standard customer now. And we create the service. We have this here. And now I can again scan this with my wallet so that I have the new credential in my mobile. There it is again. And now log into the portal with it. I send the credential again. And now we are logged in as standard customer. We can get the delivery order for no cheaper. What did I do wrong here? So probably I deleted the service that I bought. Okay. Yeah. Okay, let's skip this part. I think it already timed out. I will rather use the time to explain what we did in the background, so that you also get an idea of what was acting wrong this time. So every acquired service currently is only limited to a certain time, and then our policies do time out, which is mostly that we can reuse the same instance for demo purposes. And I probably bought it for not long enough. Okay, so but rather go to what actually happened in the background, because that's the I would say more interesting part of this. Let's start with the exact same flow that Dennis did, because in the end we're using the same system with some small differences. The most important difference to the system that Dennis presented is that normally the participants don't need an IDM system anymore. So since we are using verifiable credentials, there is no, let's say, key lock where the Happy Pets employees or Happy Pets customers should log in, but instead they get their verifiable credential issued that they then will use to authorize. We still have the key lock deployed currently because we needed to log into the marketplace, because the marketplace is not currently using the verifiable credentials for authorization, but it's something that will come at the beginning of next year. So there will be an option to have this really without any IDM system running. For Happy Pets and no cheaper, obviously, is when they don't have an IDM system to log into. They will need an issuer for verifiable credentials. You have seen one potential implementation right now that I use to issue my credentials. There are most probably different ones in the future, but we already have this one that can be used under FIWARE. And in packet delivery, we will have the credentials verifier, because we need some component that actually checks that this is a valid credential issued by someone that we trust. We still have the trust authority that will be used to verify the issuers. And we also will have the PEP proxy and the PDP. In this case, actually, we will have also the PEP proxy and the PDP as separate components, because we use a different PDP than we are using when we use the NGSI, the iSHARE policies in a way that Dennis showed that. Okay, we need some additional configuration to the things that we had before. On the marketplace, as I already showed, we need to configure the issue DID for the participants so that it can be used later in the policies. For packet delivery, we need to deploy the credentials verifier. We have to set up the DSPA PDP. The DSPA PDP is basically the policy decision point that is able to understand the verifiable credentials, to fulfill all the flows to get the policies used there and evaluate the policies. And we also need to create the roles that we can offer on the marketplace. A role in our system is also just a policy on the Authorization Registry. So this will look very familiar to you, but basically the only difference to the flow that Dennis showed is that the access subject is not another participant and not an end user from an IDP, but instead basically the name of our role. So if we define the role premium customer, we have a policy defined from our issue packet delivery with the access subject premium customer, and the policy in there as the type delivery order. It allows basically for all identifiers and all attributes a get and a patch. That would be the role premium customer that we then can offer on our marketplace to be used. And for Happy Pets and no cheaper, we need also to deploy the credentials issue, obviously, because they need to issue the credentials to their users. Okay, now you've seen that I created an offering. Actually, creating an offering in this setup doesn't need any interaction of the marketplace with the packet delivery anymore. So the employee of packet delivery simply logs into the marketplace and will create the offering with the with the information that you've seen. So basically, where's the service endpoint, which roles do we offer, which type of verifiable credentials do we support, in our case, the packet delivery service, and also all the other terms and conditions and the pricing, and what's all else to be said about offering, basically. On acquisition of an offering, we then actually have the interaction between the marketplace and the packet delivery company. The login steps are still the same as Dennis showed. The employee of packet delivery then can of Happy Pets then can select our packet delivery premium service and will perform the checkout process, including providing the payment details and doing all the payment stuff. After this happened, the marketplace will request the Authorization Registry, also again through the activation service of packet delivery, to register a policy that will register Happy Pets as a trusted issuer that is allowed to issue verifiable credentials of the certain with the certain roles to its customers. The policy that will be created in this step will look like this one. So we again have packet delivery as the policy issuer, and this time the access subject is not a role or a user or again another a participant in terms of iShare, but in this case it will be the issuer the ID that we defined previously in our marketplace. And for this issuer, we create a policy to create resources to issue resources of type packet delivery service with the roles premium customer and standard customer. So if we have this policy registered, the PDP in the future can check that our Happy Pets is actually allowed to issue such credentials. The Authorization Registry also will again run through the typical flow, the normal flows of iShare. Therefore, contact also the trust authority if the marketplace is actually allowed to do so. And that's basically what we need to have. Those roles, the acquisition process will not check if those roles actually exist, because they are only evaluated once someone accesses it later. Now we need to do the issuing of the verifiable credential that you also have seen. This will only involve the system of Happy Pets here. An employee of Happy Pet then can create a verifiable credential. This is basically how a verifiable credential looks in JSON. So we have a context, we have schemas, then we have in our case, important part of the credential subject. This is basically defined by the type of the credential. Okay, I left actually out the type of credential, should have put it in here. So a credential in our case of type packet delivery service expects to have a family name, first name, and this roles field. So the Happy Pets customer now gets a credential issued with the role premium customer and the target packet delivery. And as we can see in the verifiable credential, the issuer is also basically encoded. The customer itself can then store this verifiable credential into its wallet and use it for authorization later, which he has to do when he uses the data service here. For using it, the customer of Happy Pets will go to the portal application or to the packet delivery portal, and the portal will, for login, present this QR code that I scanned, which shows the information about how the OID, the CYP2 flow or OpenID Connect for verifiable presentations flow will be initiated. Then the customer can scan this login QR code with his wallet, and the wallet will send the verifiable credential to the verifier that is actually encoded within this QR code. The verifier here will then verify this credential. That means it will basically check that this, in our case, that it's signed correctly with the correct private key, and also that our issuer is trusted by the Trusted Issuers Registry. We're currently working on making the trust authority in iShare also, i4Trust also compatible with the Trusted Issuers Registry. This is also currently under development and will probably be available at the end of January. Once this is done, the credentials verifier basically takes the verifiable credential and exchanges it with a JWT token. This JWT token then is sent back to the portal, and the portal will contact the PEP proxy. The PEP in our case is Kong, and we wrote a small plugin for Kong that's called External Auths, or a PEP. No, it's called PEP plugin, which has a mode called External Auths. This plugin will become active once you access the once you configure it for a service, and then will forward the request to the policy decision point. The policy decision point is our DSPA PDP, and this PDP will in the end do two checks. First, it will go to the Authorization Registry and check that the issuer is allowed to issue actually this credential, which means it will check if the policy from packet delivery to our issuer DID exists, and that is actually allowed to issue credentials of type packet delivery service and premium customer. If that's true, it goes to the second step of the authorization process, which is checking that the role that we assigned is actually allowed to make this call. Which means when we get a GET call to our context broker for a delivery order, it will then check that this GET is actually covered by the policy that we did set up for premium customer. If that's okay, it will simply pass the request through to the context broker, and the portal can show the results of that. Yeah, that's more or less the whole flow. I think, I'm not sure, Dennis, do you want to talk again about something?
If you want, you can quickly go through the following slides. It's just a list of the components and material.
Yeah, so next slides is really something that you can better take a look afterwards. I will quickly go through because it simply has a lot of links to all the components that we have in here. So what you need for deploying the marketplace is something called the Business API ecosystem. We have a lot of Helm charts available for us. You can find all of them here. The marketplace consists of, basically it's a microservice architecture consisting of the logic proxy, the charging backend, and some additional APIs that will be deployed all together with their databases. We have also the identity provider, the key rock here, which needs to be deployed for no cheaper Happy Pets and packet delivery. We also have Helm charts available for that, so you can find recommendations on how to set it up on Kubernetes. You can also set it up on Docker, depending on your requirements. Then we have the context broker. We usually use OrionLD in our setups, but in the end, it's not a requirement. You can also use Scorpio, Stelio, or whatever you want. So that's another option. We link the deployments for Orion in our tutorials. Then we have the deployment of Kong. Kong is our PEP proxy that we use in both scenarios with different configurations of our plugins. One for the iSHARE policies plugin, which was used in Dennis' example use case, and the other one is the PEP plugin, which I used. Both of them are basically packaged in our Kong image to be provided for usage. You can find more detailed information about how to configure Kong here. It's usually always the same way. You set up a backend host. In our case, it's Orion, and you assign this to a certain route. This will be under the path packet delivery. So you will basically get all calls to the host of Kong with a path/packet delivery forwarded to this plugin. The NGSI iShare policies plugin needs some information about the authorization registry, the satellite, and its own identity, so that it can do the authorization in the next steps. The plugin for verifiable credentials is configured more or less the same. You again set the host and bind it to a path. The plugin itself doesn't need so much information because it only does forward the request to an external endpoint that then will do the decision for the plugin. We have some installations of a verifier and issuer or some components to act as verifier and issuer. They are also currently under development. They will also be finished at the end of January. You can already see how they are deployed in our environment. So I linked the demo environments that I used for the presentation here. We also, again, provide Helm charts for them, but they also can be run as plain Docker containers. So that's quite trivial, I would say. Then we have the packet delivery portal and the authorization activation service. Those are really only demo applications, so we don't recommend to use them in a production environment. They are only here for our demonstration purposes. But if you want to get started and play around a little, you can find all the resources to install them here. We have more information about the iSHARE Authorization Registry and the scheme owner. We again have linked it here. So Authorization Registry is available in different, let's say, implementations. You can either use the test instance from iSHARE. You can use Keyrock for that because it also implements the endpoints required for an authorization registry. And there is the alternatives to set up your own authorization registry according to the iSHARE tutorials that you can find here. Okay, that's basically a summary of the deployment instructions that I showed you here. Yeah, I hope that gets you started for your deployment. Did I miss something, Dennis? I know it was very quick, but I think it makes more sense to go through the actual links than only hear me talk about deployments.
Exactly. I propose everyone to go through this offline a bit, especially for the developers to maybe have a closer look, maybe have some hands-on where we have there's a tutorials repository linked here with instructions on how to deploy the reference example on using Helm charts. There's also another example using the OpenShift sandbox if you want to try this out. And there's also linked on our actual GitOps repository, which we actually use for the deployment of this current reference example, which we have showed here for this demonstration. So there's plenty of material to have a look on how to get the components running. But I think, yeah, then thanks, Stefan. And I think that's all from the two of us and basically also the end of the session. So I would then hand over to Rajiv again.
Yeah, thanks, Dennis and Stefan. Yeah, I think with this, we are able to conclude this session. Of course, the videos and slides will be available to you via our various channels. Specifically, you can find them on GitHub and YouTube. Do we have, I see there were some chat questions going on in chat, and Jesus has been answering them. Do we have more questions? Either please put them in chat or raise your hand so we can ask you to speak it up. I know it's already 6 o'clock. Yeah. Yes, I agree. Most of the questions. So, of course, we have regular sync with the mentors for all the experiment members who are with us in the second round of mentoring program. You have access to us as well as all the mentors who sync up with you regularly. So feel free to ask to them, or also feel free to raise technical questions in i4Trust help desk community. And of course, you can also request dedicated architecture workshops with the experts on the topics, so we can guide you on specific topics when needed. Yes, these presentations, as I said, and presentations as well as the recording of these videos will be made available. Okay, I guess no further questions, and then we can conclude this call. Thanks, Dennis, for sharing the link to the spaces where you can ask the questions. Yes, I think then we can conclude this session, and with this, we also conclude the i4Trust training camp for this this session. And I wish you all the best in your journey of implementation of i4Trust. Yeah, i4Trust building blocks and create the very first data spaces and be the front runner. Thank you, everyone, and thank you all the speakers.
Thank you too, Rajiv. Goodbye.
Thank you.
Thank you.